Here we have a problem that's similar to one of your homework problems in 12.5. It says that at a homeowners association meeting, a board member can vote yes or vote no on a motion. There are 3 motions on which each board member must vote. Complete A through C below. So on this particular problem, it says that we have 3 motions on which to vote. So those are going to be our 3 separate events. And then also notice that the only 2 options that a board member can use would be to vote yes or no. On some problems you may have an additional option of abstaining from the vote. So you would have 3 different options. Okay, so we're going to use a tree diagram to determine the number of points that are in the sample space. And then I am going to follow that up using the counting principle. Okay, so to use a tree diagram, we want to begin by starting with a dot or the trunk of the tree. And then we have our 3 motions, motion 1, motion 2, and motion 3. So on the first motion, a board member can either vote yes or no. That will have no effect on voting for the second motion. So on the second motion, if a board member has already voted yes, for the second motion, he still has options of voting either yes or no. Same thing if the board member had voted no, he still has options of either voting yes or no for the second motion. And that would be true in the third motion as well. No matter what the previous 2 votes were, the board member would have options of voting yes or no. So as we follow the branches of the tree, we've got some different answers in our sample space here, so different outcomes. If we follow the branches, the first outcome would be that a member would vote yes, yes, yes. Then yes, yes, no. Then we would follow this next branch, yes, no, yes, and yes, no, no. And then this branch would be no, yes, no, 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 yes, yes, no, yes, no. And then lastly, we have no, no, yes, and no, no, no. So I've listed all of those different outcomes, which gives me a sample space of 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 points in our sample space. We also could have come up with that using the counting principle. For my 3 separate events, tell me the number of outcomes for the first event. There are 2 different outcomes. A member could have either voted yes or no. Same thing for the second event. The second event is not influenced at all by the first, so we would still have 2 outcomes. A member could either vote yes or no for the second motion. And then for the third, the same would occur. A board member could either vote yes or no, which gives me 2 outcomes for the third motion. 2 times 2 times 2 is 8, which is the same answer we got for the number of points in the sample space using the tree diagram. And then a couple of follow-ups to that same question. Let's determine the probability that a board member votes yes on all 3 motions. So out of our sample space, we have 1 outcome where a board member has voted yes on all 3 out of the total number in the sample space, which was 8. So 1 out of 8 would be the probability that a board member votes yes on all 3 motions. And then secondly, determine the probability that the board member votes yes on at least 1 motion. So if we go through and mark how many different outcomes that applies to, voted yes on at least 1, each one of these, there was at least 1 yes except for the last one. So 1, 2, 3, 4, 5, 6, 7 out of the total of 8 would be the probability that a board member votes yes on at least 1 motion. Here we have another problem from 12.5. This deals with replacement and without replacement and numbers in a sample space. So it says that a bag contains 8 batteries, all of which are the same size and are equally likely to be selected. Each battery is a different brand. If you select 3 batteries at random, use the counting principle to determine how many points will be in the sample space if the batteries are selected. So let's first look at the problem with replacement. So what we have are 3 batteries that are selected, and since I'm using the counting principle states that we're going to multiply the total number of outcomes for each particular event times the number of outcomes for the next event, and so on and so forth. So since I have 3 separate events, I'm drawing a battery, drawing a battery, drawing a battery. We'll set our problem up this way. So when I first, we've got a bag containing the batteries. So when I first draw a battery, there are 8 batteries that have an equally likely chance of being selected. So I have a total of 8 different outcomes. Now, if I draw the battery and with replacement means I'm going to put it back into the bag. So on the next draw, there are still 8 batteries to choose from. And again, the one that I draw I'm going to put back into the bag, and for my third draw I'm going to have another 8 to choose from that all have an equally likely chance of being selected. So then the counting principle would say I'd multiply 8 times 8 times 8, which gives me 512 sample points. That's a lot to list out. So we're not going to draw it in a tree diagram, but that would be all of the different combinations of outcomes. You could have one outcome of a Duracell, Energizer, and a store brand, and then any combinations of 8 totally different types of batteries. So 512 sample points in your sample space. And now let's work that same problem, but this time we're going to use without replacement. So again, I'm going to use the counting principle. I'm still selecting 3 batteries. When I draw the first battery or select the first battery, there are 8 to choose from. But without replacement means that the one that I've selected, I'm not going to put back into the bag. So on the second draw, instead of there being 8 batteries, there would be 7. And now I'll also not replace that battery. So the third battery that I select out of the bag, there would only be 6 left in the bag. So 8 times 7 times 6 is 336. So there would be 336 sample points in that sample space.